In this video, we're going to talk about significant figures and scientific notation. So, we'll just talk about the purpose of scientific notation. So, scientific notations is essentially, excuse me, scientific notation is essentially an easier way of writing really big numbers or really small numbers. So, suppose for instance, I were to write this number here. Okay. So how would I write that number with, say, two significant figures? Okay, so two significant figures. Okay. Also known as significant digits or sig figs. So how would I write this huge number here to two significant figures? Well, the way I would do it is this. What I would do is I would just use the first two digits here. So I would use 4 and 5. All right, so I'd write that down here. 4.5. Okay, so you put a decimal right after the first number, and then you'd write times 10 to some power. Okay, so some power here. So what we're going to do is we're going to start where the decimal is. So in this case, it'll be right after the 4, and then we'll just count all the way to the end of the number. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so it'll be 8 decimal places. So that means it'll be 4.5 times 10 to the 8. Right? And that's how we would write that number with two significant figures. How about we wanted to write this number instead of with two significant figures, but we want to write it with four significant figures? The process would be pretty much the same, except we would use 4 digits instead. So we would write, instead of using the first 2 digits like we did here, we would use the first 4 digits. So 4, 5, and then 0, 0, 1, 2, 3, 4. So we would do that. So with 4 figs. Right? So to do it with 4 sig figs, we would do it like so. So we'd write 4.5, 0, 0, and again we're going to do the same thing as we did before. So we're going to start where the decimal is, and then we're going to count to the end of the number. So 1, 2, 3, 4, 5, 6, 7, 8. So 4.500 times 10 to the 8. Right? If you wanted to write it with 3 significant figures, okay, it would be 4.50 times 10 to the 8, and so on and so forth. So that's significant figures. How about we have a number, we have this number for instance, okay, so we have this number, okay, so we'll use right, and we want to express that to 3 significant figures. How would we do that? Well, again, the process is exactly the same. So what we would do is we would write the first 3 digits, putting a decimal after the first number. So it would be 3.35, okay, so times 10 to the, so we'll start where the decimal is, 1, 2, 3, 4. So times 10 to the 4, like so. And the reason why we round this up to a 5 is because of this 9 here. Since we're only using these 3 digits, this last number here has to be more consistent with the rest. So we would round this up to a 5, and hence we get that. If we were to write it to 4 significant figures, for instance, we would write the first 4 digits and then times 10 to the 4. So it would be 3.349 times 10 to the 4. Okay, so those are really big numbers. How about really small numbers? Now, how do we write really small numbers in significant figures? So as we saw here, if we're moving the decimal places to the right, okay, if we're increasing the decimal places, we're going to increase the power. When we're writing really small numbers, on the other hand, we're actually going to decrease the power. So let's say we have this number. I'm just going to write another number here. We'll write, say, I'll come up here, use this space. How do we write this number here? 0.000211. And we want to write this number to 3 significant figures, okay? How do we write this to 3 significant figures? All right. So again, the process is the same. So we would write down sorry, I'm just going to change colors here. So what we would do is we would write down the first 3 digits, the first 3 non-zero digits. Okay, so that would be 1, 2, 3. So 2.11 times 10 to the something. So again, we would start our decimal right after the 2 here, and we're going to count backwards to the decimal. So 1, 2, 3, 4. All right, so it would be times 10 to the negative 4. Okay, and that's how you write it with 3 significant figures. If you wanted to write it with 2 significant figures, okay, if we wanted to write it with 2 significant figures, it would be the same process. We would just write the first 2 non-zero digits instead of the first 3. So to 2 significant figures, it would be 2.1 times 10 to the negative 4. Okay, so using significant figures, or excuse me, using scientific notation is really helpful when you want to write really big numbers, because as you can see here, this is a really large number and it can take up a lot of paper space. So it is much easier to write it like this, which takes up less paper space. Like for example, you can get a number like this. For instance, you can get you can get a number like this, right? You can get a number like 5, 9, okay, so, and let's say you're doing calculations and all that, and you want to fit that onto a piece of paper without taking up too much space. How would you write this, right? Obviously you're not going to be writing this whole entire answer. A much easier way would be to use scientific notation to make the answer a little bit more readable. So for example, if the test says to write it to 3 significant figures, we just use these first 3 digits here, and the rest is history. So what I would do is I would write 5.98 times 10 to the something. So again, what I would do is I would start right here. I start the decimal right after the 5, and I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, So this would be 5.98 times 10 to the 14. So now we're going to segue into significant figures and determining how many figures are significant in a number. This is especially important when you're doing calculations, so addition, subtraction, multiplication, and division. There are different rules for those calculations, which we're going to talk about in a bit. But first, you have to understand uh, how many significant figures there are in a number when you take a look at it. So there are a few rules for determining significant figures, and I have them right here on the left. And I know they do seem a little bit abstract at first, so we're going to do a few examples on the. So here are the rules. So first of all non-zero numbers are significant. So if the number is not a zero, it is considered significant. Zeros between non-zeros are significant. And then trailing zeros that come after a decimal are significant, which is to say that leading zeros are not significant, and trailing zeros that don't come after a decimal are not significant. All right, so if you look up here, all right, we have 4 numbers right here. Okay, so how many significant figures are there here? Well, we have 1, 2, 3, 4. All 4 of these are significant. Okay, so we have 4 sig figs. Now, how about this one? Okay, and it's sort of a similar deal here. We do have zeros that come after a 5, which is after a decimal, which is okay. The zeros between the non-zero numbers, so all these numbers right here are considered significant. So 1, 2, 3, 4, 5. So this number has 5 significant figures. All right. How about this one? Okay, so we have 21 million. Okay, 21 million. How many significant figures are there? So if we look back onto our rules, obviously all non-zero numbers are significant. So the 2 and the 1 are significant. There aren't any zeros between the 2 and the 1. And there are no decimal places. Okay, so that means you have to kind of go down to these rules here. Trailing zeros that don't come after decimal are not significant. So as you can see here, there's no decimal place here or anywhere here. So that means all these zeros are not significant. Okay, so that means there's only 2 sig figs here. Now how about this one? Okay, so we have a similar looking number except there's decimal here. Well, according to this rule here, trailing zeros that come after a decimal are significant. So these 2 numbers are significant, and these 2 are also significant because they are non-zero. So that means all 4 of these digits are significant. Therefore, we have 4 significant figures. And how about this one? Okay, so 0.00360. How many significant figures are there? Well, remember that trailing zeros are not significant. Oh, sorry, leading zeros are not significant. Okay, so this 0, these first 3 zeros don't count. We're not going to count them as significant figures. The 3 and the 6 are non-zero, so they will be significant. And then this 0, okay, will also be significant, and the reason why is because it comes after a decimal, which is here. So that means this would be this number right here would have 3 significant figures. So that will take us to the next video where we will discuss the different rules for addition and subtraction, as well as the rules for multiplication and division with respect to significant figures. See you then.